In the last section, we learned about the big ideas of hypothesis testing. In this section, we're going to begin to formalize those ideas and be a little bit more careful about how we think about a hypothesis test. The first thing we're going to learn is there's actually more than one hypothesis in a hypothesis test. There is two hypotheses actually, H sub 0, which we call the null hypothesis, and H sub A, which we call the alternative hypothesis. The null hypothesis is similar to the kind of hypotheses we thought about when we were thinking about the big idea of hypothesis testing in the previous section. This is kind of the default assumption in a lot of circumstances. We assume this to be true when conducting the test. H sub A, the alternative hypothesis, is a complementary hypothesis. That is, the two hypotheses are complementary. One of them has to be true. And only one could be true. Okay? When we're conducting a hypothesis test, we're usually trying to gather evidence to prove the alternative hypothesis. When conducting a hypothesis test, we are usually trying to gather evidence to prove the alternative hypothesis, HA. Now, as I mentioned, these are complementary hypotheses. These are complementary mathematical statements. One of these two hypotheses has to be true. If the null hypothesis isn't true, then automatically that means the alternative hypothesis is true. If the alternative hypothesis isn't true, then automatically that means the null hypothesis is. And only one of them could be true at a time. Okay? So there's actually special symbols that we use when describing the null hypothesis and when describing the alternative hypothesis. Okay? For the null hypothesis, we always use a symbol with an equal in it when describing it, using a mathematical statement. So we could use equals, or less than or equals, or greater than or equals. Those are the three options we can use when writing a mathematical statement for the null hypothesis. The alternative hypothesis is the complementary mathematical statement. So it's always the opposite symbol. So the opposite of equals is not equals. The opposite of less than or equal to is strictly greater than. The opposite of greater than or equals is strictly less than. Okay? Notice the null hypothesis, every symbol that we use for the null hypothesis has an equal in it. Every symbol we use for the alternative hypothesis does not have an equal in it. That's a good way to determine whether the mathematical statement we have corresponds to the null hypothesis or the alternative hypothesis. Now, when conducting a hypothesis test, there's only two options. So possible outcomes from a hypothesis test. Either we reject the null hypothesis and accept the alternative hypothesis, or we do not reject the null hypothesis and do not accept the alternative hypothesis. Forgot the word reject over here. Do not reject the null hypothesis and do not accept the alternative hypothesis. These are the only two outcomes that can happen in a hypothesis test. Now this corresponds to what we were doing in the previous section. Previous section, we formed our hypothesis, we gathered a sample, and then we found the probability that we would get that kind of sample given that we assumed the hypothesis was true. That hypothesis we assumed to be true was like the null hypothesis. Okay? If the sample we got was extremely unlikely, would be very unlikely to get if the null hypothesis was true, then we'd say, you know what? We don't think we're that lucky. We think that in fact the null hypothesis isn't true. And so in that case, if our sample data is deviates far enough from the null hypothesis, we might reject the null hypothesis, say we don't think that's in fact accurate. We instead accept the alternative hypothesis. Okay? Alternatively, maybe our evidence from our sample data isn't as strong as it might be. Okay? Maybe it might suggest the null hypothesis is wrong, but the evidence really isn't very clear. We do not have enough evidence to reject the null hypothesis, which means we do not have enough evidence to accept the alternative in its place. Okay? Now, these are the only two outcomes that could happen from a hypothesis test. Notice there is no outcome that says we accept the null hypothesis and we reject the alternative hypothesis. That's not what we're trying to do here. We are trying to determine whether or not we have enough evidence to accept the alternative. We are not looking for evidence to accept the null hypothesis. Okay? And that's not something we can do with a hypothesis test.